Hi guys, welcome. Hope everybody has a happy Wednesday. So what we're going to do today is finish up the notes on the graphing logs and expo day 1 worksheet. Okay, so if you're looking through this, we talked about Monday, we talked about how to graph and go through things, okay? And also how to identify if something is growth or how something is decay. So that was on Monday. Then yesterday when we were looking through things, we talked more about the rates, okay? So how does something look? Remember the equations were, when I was looking at them, it was y equals a, 1 plus r to the t. That was my growth equation. And my decay equation is y equals a, 1 minus r to the t. A is your original amount. R is your rate. Remember, you have to change that percentage to a decimal. So you divide that percentage by 100 to get the number to plug in. And then T is my time. Okay? So we had problems like that. And then today what we're going to do is talk about something that I know you've talked about before in personal finance. We're going to talk about compound interest. So what does that look like with things? We're going to talk about that here. So the equation to find compound interest is A equals P. P is your principal, so that's the amount you're putting in, or the original cost, or something like that. 1 plus R over N to the N times T. R is your rate, just like it was in growth and decay before. N, though, is different. N is the number of times compounded, okay? So number of times compounded. What's unique about that is that sometimes we have to think about it. So when they say semi-annual, okay, I think of Nordstrom's. And I'm like, oh, semi-annual, that happens twice. So my N would be twice. When they say monthly, well, there's 12 months in a year. That would be 12. Daily, 365, okay? And then T is your time. So let's go down here and look at this problem down here. And let's do this one. So it says you deposit $9,000 in an account that pays 1.46% interest. Find the balance after 3 years when the interest is compounded quarterly. So let's first set that equation. So y equals, right, our original amount, which is $9,000. So I'm going to plug in $9,000. 1 plus my rate. My rate is 1.46. The biggest error I'm going to see there is that people put 1.46. Nope. It's 0.146 all over a decimal, right? And then number times compounded. Well, it's compounded quarterly, okay? This is something used a lot in the finance world, but think about quarters. There's 4 quarters in a dollar, so when they say compounded quarterly, it's 4. And then we're just going to put 4 times t, because I just want to write the equation first. So let's look at that. So let's simplify it down a little bit. So I get y equals 9,000. Okay, this is where it gets a little bit confusing here. And people are always like, what do I do? How do I simplify this down? Well, what I would suggest do is do the 0.0146 divided by 4 first on your calculator and then add 1. So I would do that first. It makes your life a lot easier when you do it. And when you do that, you get 1.00365. Now some of you guys are like, why are you writing down so many numbers at the decimal point, love, Chuck? Well, the more you write down your decimals, the more accurate your number is going to get. So if I just put 1.0, that's not going to give me a true indication. I want to make sure I have, a few numbers after the decimal point to make that a little bit easier. So this would be my equation right here. So let's say they wanted me to know for 10 years, or 12 years, or 17 years, or 50 years. All I would do is take that number and plug it in for t. But right now they're saying, okay, find it for 3 years. So what does that look like? Well, all I have to do, in place of t, I'm just going to put a 5. So I get y equals 9,000, 1.00365, and I'm going to do 4 times 5. I know most of you guys, just go ahead and simplify that down to 20. Perfectly fine. Actually, they wanted 3 years. Let's go back and erase that. So let's put 3 years down there. So I know most of you guys would put 12 there, but I'm just going to do it like that. You could simplify that down to 12, obviously. So I get y equals 9,000, 1.00365 to the 12th. So when I'm entering this in the calculator, I can enter it in all at once. Just make sure that I have my parentheses there, because order of operations, I'm going to have to take it to the 12th power, that 1.00365, before I multiply by 9,000. And if I don't do that, then it's going to give me the wrong answer. So when I do that, and I type that in my calculator, again, we're talking about money here, so when I round my final answer, I'm going to round it to the nearest penny. So I get $9,402.21. So if I invest $9,000 in 3 years, I'll have gained over $400. Pretty decent investment, I think. Okay? So that would be the answer I'd be looking for. Again, this up here is my equation. It's really important to be able to write that out with the information given. And then my final answer. Okay. The last thing that's not on here, but I think it's pretty important, we're not going to do this one here, to know how to do, is also, what did you talk about compounding continuously? So this up here is talking about compound interest, but what happens when you're compounding something continuously? This will definitely probably be on the ACT. So let's talk about compound continuously. Okay, interest. And I'm sure you guys have all heard this before, and it's PERT. So how do you know if something's compounded continuously? Again, realistically, not something that happens really in the real world. It would be nice. But let's say it would be A equals P e to the RT. So A is still the amount of money at a certain time. P is your principal. E is just, the number on your calculator. And then R is still your rate and time. So let's do that same problem from above with the 9,000, the same rate, the same time, and let's see what would it be in PERT. So that means every single second and millisecond, it's compounding, it's gaining more interest. So let's see here. So we would do that in order to use the same thing. We would get A equals 9,000 E to the rate, which was, we know, the rate above was 0.0146. So I would do E to the 0.0146 times my time, and our time there was 3. Okay? So after 3 years of my rate, now when I'm doing this, what I would suggest to do before you enter in all your calculator is that you multiply by the exponent first. It's just going to make your life a lot easier. So when I do that, I get A equals 9,000 E to the 0.0438. And then from there, I just type that in my calculator. Your E button, if you're using the Inspire, is next to your 2 over from the number 1. So it says E to the X. That's what you're going to be using there. So you do 9,000 E to the power of 0.0438. Enter that, and you get almost the exact same amount, but it's just a little bit more. Barely any, but hey, every penny counts. So I end up with $9,402.96. Okay? So there is no questions on your worksheet over PERT, over compounding continuously. It is something you've talked about in personal finance, but I do think it's important for you to see and recall it. Again, if you have any questions or anything, make sure you come to Zoom today at 9 a.m. Your assignment is due Wednesday by 11:59, and then we're going to start graphing by transformations. Have a great day. Thanks for stopping by.